So we have here, I have loaded all the tools I will use and the sample project. So just let's get started. I will switch to level 1, and you can see here walls, modeled composite walls. So I will start from the tool Smart Walls, and first thing that I will do, I will decompose walls. So it means that I will separate all the layers of this wall, and we will have 3 different walls, as you can see here now, 3 different walls with the same name set as it was the layer name. And yeah, so when you work with architects and you want to separate your part from the architect part, you can use this function. And if you have windows in the wall, so okay, I'll do the same. I will decompose this wall, and you can see that we have openings in all 3 layers, and if someone will move the window, then you will have all the openings in all the layers. Yeah, so you can just switch off them, and you can see the openings left in the structural layer. So that's one of the function of smart walls. Next, let's say we have precast walls here joined together. We can select all of them and use other thing to disallow joints. But after we use this command, we will have gaps between the walls, which we can configure by the wall type. So I will just do now disallow joints, and let's see the result. We will have, yes, now we have separated walls with a disallow joint at the end, and we can choose the command shorten pick wall. I will choose this end, and we will have a shorter wall. We will do the vice versa connection of these walls. So yeah, you can see now we have a short wall here with the gaps as defined for the wall type. Now we can also do one more thing. I will select these 2 walls, and I will use command split walls. So I select the grids and click OK, and we will have separate walls here, split it with a defined gap. So you can see we have here now walls. So if you work with precast elements, it's pretty good, because you can just draw grid lines where you want to have your panels separated, and use this function to quickly split walls. Okay. Yeah, you can also insert gravity points into your wall elements. So if you select just a wall element, you click insert gravity point, and you can see gravity point inserted into your wall panel. I have here the big wall panel. Okay, so you can do this for one wall, or you can have a gravity pull for the group of a wall. So you can use it also when you need to define some lifting devices space. Okay, and next tool I want to show you, it's smart floors. So I will switch to the second floor plan, and I will insert some floor panels here, hollow core slabs. So I will switch to Smart Floors tool. I select Insert Update function, and we have here configuration window, and I will give a name for the group, and I will pick the supports for my floors. So supports can be beams, walls, reference planes, grid lines, and so on. So we add parameters to the floors, and we choose the floor type. We choose to insert the holes into the floors, and yeah, so this is the type for a massive slab. So I will just click insert. If we have a gap, we will have a massive slab. So okay, let's see now. We have here panels inserted, so floor elements. So you can see here now floors added, and we can modify them, we can split them, we can select again different support if we want to update them. Yeah, if I will change the size of a massive slab, I will click on update, and okay, so we can update, we can just always follow the changes in the project. We can also insert holes into the massive slabs and so on. So there's some additional functionality. We can also use insert gravity points. So if we want to, it's the same as for the walls. Okay, let's just switch to the 3D view and switch to the another tool. So I have here some steel elements, and if we want to cope, when by default you draw the truss family, we have here web elements not cut it according to the charts, but you can easily solve this with our tool. Okay, I will choose the sort and cope tool. I select the truss and I select the command copes elements of the trusses. Okay, and here we have coping distance. I'll click OK. And let's see, so we have now pretty good looking truss just with a one click, so I think it's very good. And then again we have a lot of commands here to cope beams connected to structural columns. We can set up here coping distance, and you can see it was cut according to the column. We can select beams, and we can cope selected beams, and then again the coping distance, and we can see here it was coped according to the other beam. So it's we have here a lot of commands to add or remove copings in the elements, so we can use it. Yeah. Next tool is insert elements. So I like this one very much because you can quickly insert elements into your project. Like if I will select these 4 columns and I will go to insert elements tool and hit insert elements by related objects. So it reads the project, and I will insert foundations, just a regular family of foundation here, and I will put it at the bottom of a column with a elevation offset. Okay, so we have here foundations inserted, but and we can do a lot of things with this tool. I can select all the columns and then again insert elements by related objects, and then if I will choose structural connections, then I can choose like column shoes. We used them a lot, and insert elements at the bottom of a column. I will hit insert, and it's inserted at the bottom of each of the columns, and we can also insert balls Okay, at the top, and then again insert, and okay. Yeah, so you can see now that we have elements added here, like balls and column shoes, just with few clicks to all of the columns. So it's like very quick, and very good thing for this command is that we have developed a method such that elements adapt to the geometry properties of a hosted element. So if I select two beams with a different width, and I will insert elements again, and I have like nested family of connection details with a distance which is equal to the width of a beam. So I have here set up the distances for the array, and I click insert, and let's see. Now we have the same family inserted to this beam and to this beam at the edges, so you don't need to adjust them manually. We just got the width of the beam. So it's the same for the other families also, for the columns, connection details, and so on. So there are a lot of options in this tool, but just I wanted to show you just impression of the possibilities of it. So yeah, so let's just switch to the other tool. We have openings here we want to cut through the elements. So we have pipes and ducts crossing our elements if we work with MEP engineers, and if we want to make openings in the place where these pipes are crossing our elements, so for this we can use tool cut opening. But first of all, we have to run interference check with Revit and use interference between these elements and our elements. Okay, and walls and floors, and click OK. So we have report of intersection, and we will export this report. We'll place it on the desktop. Okay, and now let's switch to cut opening. Here we have a configuration window where we can set up some options if we will join or we will not join the openings in the bunch of pipes, and if we will cut elements when it only intersects, and what is the minimal opening size. So we do the configuration, and we read the interference data. Okay, and now we browse to the file we exported. Okay, sorry. Hey, select this document. Let's see the report. Okay. Okay. And we have here I will switch host, and we have here all the crossing elements. If I select this, you can see it in the dynamic box where it crosses my elements, so I can review and I can decide what to do. Like I can add a cutoff set for the opening. I will change this value to 20. I can change this value to, let's say, 50 for this element. I will also would like to change this value to, let's say, rectangle shape, and let's click go to insert, modify options, and click OK, and OK. Yeah, so the software is processing data, and we will see the results. This tool works with all line-based elements, so it does not have to be only pipe elements. It can be any form elements. And it works with linked files, and it works with as many elements as you need. So I have only 7 openings, but of course you can have like 1,000 at once. So let's just switch back to Revit. Okay, so you can see here it is a rectangular opening as I defined. I have opening in framing element. I have openings here, connected opening for the 3 of them because we are near, and we have a big opening, and so on. So it's the same as it was in configuration window. So it's very good tool if you work with MEP engineers to update your data and so on. So that's great. Okay, so if we done with modeling, we can go for some documentation tools. So I switched to the column plan view, and we can see here now that my columns marks are empty. So we have question marks here. So I want to make some quick numbering of elements as defined in my company, let's say. So I go to sort mark tool and select the element numbering command. So I select element numbering, and let's go. We have columns. Okay. Is everything fine with the sound? Okay, so let's continue. I think everything is okay. Okay, so we have structural columns selected, and I will click OK, mark, and click OK again. I will write values to the mark parameter. So I have configuration saved here with a grouping, numbering, and sorting of elements, and I have selected parameters to write according to a material model behavior. Like for steel, for concrete will be different values, and I have prepared numbering. So I will click OK, and we have 63 elements numbered, and now we can see that all the marks are updated of a column. We can zoom in. My configurations was like to show model behavior, to show the material, to show the place of the column, and the number. Okay, so let's switch to the second floor, and you can see here that here we have a steel column, so it has a different beginning. For the steel we have S number, and for the precast elements we have PEC. So that's the quick method to number our elements. We can do the same with floors and with beams, and whichever elements you need to renumber. Like I will select element numbering again, select floors, click OK, and I will write values to the mark parameter. And again, I have some configuration prepared. Okay, so you can use this in any project. You just configure it once, and you can use in all other projects with configurations. So I have also my values here defined. So that's again, we can also use the grid numbering if you have such a mess as in my case, like we have not the right number of axes. So you can select all of them. We can automatically or manually change the values of grid access, so you can fix it quickly also. So yeah, so there's more options in this. Okay, so it's a quick numbering and marking your elements to the defined rules. Let's go and add some dimensions. If I will go to the first floor, okay, let's go to the tool quick dimensions, and now we have here configurations. Like we can set up and save different configurations. Like for beam, I have created like this one, for columns like this one, columns, walls, and grids this one, and let's just use this one. I will click the point from where to start and the point where to end. So I have here dimensioning line inserted with all the dimensions. And yeah, so you can use quick dimensioning for this. You can also, let's choose the grids, and let's do this like this. Okay, so you have distances between grids, and you can also have different options for the wall dimensioning configuration. So you can also select here like how they could be dimensioned. Like if I will select this and I will select the place, so I will have dimensions like this, or I like the other options in other configurations, like this one. I can just insert dimensions and so on. So you can quickly insert dimensions into your project. Okay, next thing with the documentation part. If we have a drawing, we will insert it into the sheet, I guess, I hope. Okay, and I will insert first floor column plan. I will insert first floor column schedule, and according to this layout of my elements, I will create other plan sheets. So I will use smart sheets for this. I will choose manage sheets option, and I will I have here my template sheet, and I will create new sheets now according to this template sheet. So I will select the schedule tables for second and third floor of the columns, and I will select the second floor and the third floor of the column plan. And let's click OK. We have here options what to copy from template view, template sheet, and we have now to select just where to place what. We have schedule table level 2, and we have schedule table level 3. I will click OK. We have new sheets created. I will click OK here. OK. And we have now 3 sheets. I can just change the name of the sheet according to the name of this view. So you can see here the name of the sheet is changed, and if I will go to the second floor, if I will go to the third floor, I already have these plans and schedules inserted. So it's a small project and just a few sheets, but you can use it for as many as you want. So this is to increase your productivity by using smart sheets and preparing your documentation. Last but definitely not least tool, Excel to Revit. So we can insert Excel tables to Revit and link them to Revit. We can follow updates of Excel file. So in this window, I will select the Okay, I will select my Excel file. I will click open, and I have few spreadsheets in my file, so I can select like okay, this one, quantities. Okay, I can just change my name if I need to, and I can use the text and line styles according to the Excel, to the Revit, and so on. So we can configure this one and just draw the table, and let's see the result. Okay, and we have here in the drafting views, we have this Excel table inserted. We can do the same with all the information we have in Excel files, like if we have prepared some steel notes, and again draw table, and click OK, and let's see. Yeah, so you can see now we have also the text inserted in our Revit file, so we don't need to rewrite, or we can just use it if we have it already. So yeah, you prepared, and you can just drag them into your sheets and print it out and just work with your files. If I will change Excel file, okay, I will just, let's say, I will change the length values. I will, let's say, I will change this one. Okay, and I will save it. Okay, let's go back to Revit and manage tables. Okay, and update truss quantities we see there. Okay, we see the modification data and data loaded to the Revit. Okay, and let's see if we have Revit file updated. You can see here now we have 2000 instead of 1000, and everything is updated, and you can be sure you have the last data in your project. So that's it. That's what I wanted to show you in this presentation.